Today's topic, computer hardware. For this talk, we won't get too detailed into how computer components work or argue why one brand is better than another. The point of this talk is to show how computers work in general, to introduce you to different components that make it work, and to highlight correct terminology for everything. The focus here will be on desktop computers, but laptop computers are pretty similar in most aspects. Let's start off with something really basic. What is a computer? So what exactly is this thing? Some people call it a tower and others call it a hard drive or CPU or the computer. Technically, those are all incorrect. There are some computers that lie flat. Can you call those towers too? It's not a hard drive or a CPU. Those are components on the inside of the case, which we'll cover later in this talk. It's also not a computer by itself. Technically, this thing is called a system unit. No one ever uses that term, but in case you hear that someplace, you know that they know what they're talking about, or they're getting ready to go on Jeopardy. So that box is not a computer by itself. Technically, a computer is an electronic device that takes inputs, processes those inputs, produces outputs, and saves that for later use. Think about that one and all the things that might be laying around the house. Your cell phone is a computer. It's electronic, it can take an input, process that input, produce an output, and save it for later. Your remote control for your TV is not a computer. Yes, it can take an input and produces an output, but there's no processing involved. You're basically pushing a button to make electrical contact with something to send a signal to a receiver. There's no thinking involved, and there's no way to store anything unless you have a fancy programmable remote. There's a difference between a computer and an embedded computer. Tesla has an embedded computer, as do thermostats like the Nest and Ecobee. Their primary function is to provide transportation or to regulate the temperature in your house, and computers help them do that. But these devices themselves are not considered to be a computer. People sometimes call a Tesla a computer on wheels, which is not really the case. What you see here is referred to as the information processing cycle. This shows how the major components of a computer work together to bring you your PowerPoint presentation, your Amazon wish list, or your Gmail. Everything starts with input devices. An input device is something that you as an end user use to communicate with the computer. It's your way of getting data into the computer so that it can do something. You can click, talk, or type something, or you can take a video of yourself doing something, or you can scan a document in for editing. Trick question, is a USB drive an input device? Technically, no. It's in the name. It's a drive, and drives are storage devices. Plus, when you think about it, when you plug in a USB drive, you're not doing anything to actually input data. When you scan a document, you're putting a document on a flatbed and pushing a button to initiate the scan. When you click, you're maneuvering a mouse to an icon and pushing a button to trigger something. When you plug in the USB drive, all you did was plug in a USB drive. You're not inputting anything. You're just inserting a drive, just like you did when we used to use CDs and DVDs, and for the older crowd, floppy disks and zip drives. Whatever you input is generally put into memory first. Let's step back and talk about the binary system. Computers only know two states, on and off. There's an electrical charge or there isn't one. There's a magnetic positive or there's a magnetic negative. There's always one or the other, and this on-off state is how computers compute. A bit represents that on-off state as either a 0 or 1. A byte is 8 bits. From there, we have our usual prefixes like kilobyte, megabyte, and gigabyte, which indicate 1,000, million, or billion bytes. If you want to get technical about things, a kilobyte isn't exactly 1,000 bytes. This has to do with how binary works. A kilobyte is actually 2 to the 10th power, or 1,024 bytes. A megabyte is actually 2 to the 20th power, and a gigabyte is 2 to the 30th power. If you ever see something about your free hard drive space or memory in use, and it's not a perfectly round number, this is why. So back to memory. Memory is sometimes called a storage device because it stores your input. To differentiate this from your hard drive, some people in the IT world call it primary storage. Most people simply call it memory or RAM, which stands for random access memory. If you open your computer and see something that looks like this, that's what memory looks like. In a laptop, it's probably half the width, but it still functions the same as desktop memory. Inside your computer case is the motherboard, which is the large board that everything is plugged into. Your memory usually sits in slots like this one. The yellow and orange aren't a standard color. Sometimes those slots are black, white, purple, or whatever color the motherboard manufacturer felt like choosing that day. Memory for a computer is similar to a desk for a person. When you're working on things, your desktop is where all your stuff goes. As your computer takes more inputs, memory fills up. If you ever notice your computer running slowly, that might be because it's out of working space. Just like people, if we need more space on our desktop, we need to rearrange things or put things away. Your computer also tries to rearrange things by moving some of the data to your hard drive to make space for more inputs. As the end user, you can also close programs to free up that working space. The alternative would be to simply increase the amount of memory you have. If someone suggests upgrading your memory, that's essentially getting yourself a bigger desk to put your stuff on. More working space means you can do more at once. If you're buying a computer, look out for something that says GB or DDR something or RAM. That's how much memory comes with your computer. Generally speaking, most home users don't do much on their computers. They watch YouTube videos, check email, and maybe do some light personal accounting. They don't need a lot of space, so a general rule of thumb is to look for a computer with at least 8 gigabytes of memory. Obviously, more is better, but there is a point of diminishing returns. 16 gigabytes is generally generous, and anything above that for casual everyday users is probably overkill. Upgrading memory is simple to do, but be careful that you're buying memory that works with your computer. Your best bet is to look on a site like Corsair.com to see what they recommend for your computer. Or if you're feeling adventurous, open your case and look for yourself. Take note of how many empty slots are available and what kind of memory is in there now so you can shop around for memory that works for you. Moving right along, the next part of this information processing cycle involves your central processing unit, or CPU. CPUs are generally made by either Intel or AMD. Apple makes their own for their product line, and there are other manufacturers that make CPUs for mobile devices. CPUs are usually small and connect directly to a motherboard. On a motherboard, your CPU usually sits under a fan and heatsink. In this example, the CPU is under a liquid cooling system. CPUs are measured by how many cycles per second it can complete. A cycle involves getting chunks of data from memory, processing it, and putting it back into memory so that it can be output to the user. A hertz is a cycle, and if you remember the prefixes we use when talking about bits and bytes, we have processors that run in megahertz and gigahertz speeds. If you're shopping around, processors will sometimes be listed by name and model. In this case, we're looking at an Intel Core Ultra 7. You might see something about a core. In this case, there are 20 cores. A long time ago, processors consisted only of control unit and an arithmetic logic unit, or ALU. There came a point in time where someone thought that if we take that package, make it small enough, and then add a second one, we could make CPUs run faster. That became a dual core processor where each core is a control unit and ALU combo. Nowadays, you may see 6-core or 8-core, or in this case 20-core processors listed in the description. You also might see the speed rating. In this case, our processor runs up to 5.3 gigahertz or 5.3 billion cycles per second. For most casual users, your processor specifications aren't as important as having a good amount of memory, but if you really want good performance because you're making movies or playing games, higher numbers are generally better. The only other thing to decide on is going with Intel or AMD. Generally speaking, Intel chips can crunch numbers faster, so for businesses doing a lot of intense math, you more than likely will see Intel CPUs. AMD is generally good for gaming because of how you can push it beyond its limits. Plus, AMD processors are generally less expensive than their Intel counterparts if you compare speed to speed. So we have data coming into the computer through an input device. That data sits in memory until the CPU is ready to process it. Once it does that, the result goes back into memory and is ready to be output to the user. Output devices include anything that your computer uses to talk back to you. This would be through displays, printers, speakers, and even the little motor that vibrates your phone when you get a text. That's all great for when you're working, but once you're done and need to stop for a bit, you need to save your work someplace. That's where storage devices come into play. Memory is sometimes called primary storage, and storage devices like hard drives, DVDs, and USB drives are sometimes called secondary storage. Again, most people just call them storage devices or hard drives. The same concepts from memory will apply here as well. Storage devices work on binary principles and are measured in megabytes and gigabytes, just like memory. Inside the case, hard drives are usually in a tray or rack and are connected to the motherboard through cables. Most computers that you buy from the store will only have one hard drive. This one has 5. As long as you have space in your case and enough ways to connect them, you can put as many hard drives in a computer as you want. The term hard drive usually refers to a drive that has a spinning platter and a read-write head. You normally don't see the insides like this. Hard drives are sealed in a metal housing to protect it from dust or other particulate matter. The platters are coated with magnetic particles that are oriented in one of two ways, and the read-write head can sense that positive or negative polarity, giving us our zeros and ones. Optical drives like CDs and DVDs operate on light reflection. The shiny side of a CD or DVD is actually a series of lands and pits that either reflect or disperse a light source. That reflection or dispersion gives us our zeros and ones. Scratching a CD or DVD was sometimes bad because that would interfere with the sensors trying to detect that reflection. You don't see optical drives much in computers nowadays, but some gaming systems still use them, and this principle works the same there as well. Solid-state drives are generally smaller than hard drives. These are much faster than your traditional hard drives because there are no moving parts. They're also a little more expensive if you were to compare drives with the same capacity. Like hard drives, solid-state drives are usually enclosed. You might see a solid-state drive that looks like this. It looks like memory, but note that the connector is on the short side instead of the long side like memory. These are faster than the other drive we just looked at because these connect directly to your motherboard. USB drives also fall under the storage category. They are technically solid state drives because they don't have any moving parts in them, but we usually don't call them that because that can get confusing. We usually refer to them as USB drives, jump drives, thumb drives, or removable drives. If you're looking for a computer, the specs will sometimes say if it comes with a hard drive or SSD, so look out for verbiage like that. Generally speaking, 250 gigabytes is good for most casual users. When you think about all the things you save, it's not much. Even if you have years of tax records and family pictures and MP3s from when we used to pirate music, that doesn't add up to much. And even if it did, you probably have a lot of that stored on an external drive or in the cloud, so having that much on your computer doesn't always make sense. Anything more than 250 gigabytes is a bonus. Storage is generally cheap, so you won't see a lot of savings between a 500 gigabyte and 1 terabyte drive in a computer if all else is the same. I just mentioned cloud storage as an alternative means of storing data. Anytime someone mentions cloud in an IT sense, they're referring to the fact that it's somewhere on the internet. Cloud storage then is storage in another location that you access through the internet. There are pros and cons to doing this. For one, you don't have to purchase a computer with a lot of storage, as we just mentioned. Putting all your files in the cloud means that you don't have to worry about space limitations. In addition to this, having files in the cloud makes it easier for you to access them from anywhere and on any computing device as long as you have an internet connection. On the other hand, putting files in the cloud is risky because you're trusting some other company to safeguard them. Cloud providers have been targets of cybercrime lately, so your hope is that they are doing all they can to protect your files. Using the cloud could also be a problem because of that need for an internet connection. If you travel to someplace remote where internet service is spotty, you're not going to be able to access your files easily. In the end, it's really up to you to decide what risks you're willing to accept and what cloud provider you want to trust. And that's your information processing cycle. Computers can sometimes act up, and if you're not going to fix it yourself, you're probably going to take it to someone or someplace that knows what they're doing. In that case, it's important to remember the correct terminology. If someone were to bring me their system unit and tell me that their hard drive isn't working, I'm going to think that they're talking about the metal box inside the case with the spinning platters. But if that user is used to calling their system unit a hard drive, that's going to lead to some confusing conversation because troubleshooting and fixing a system unit is very different from troubleshooting and fixing a hard drive. Not only is it important to know what components are supposed to be called, you should also have a good understanding of what they do. Sometimes when computers are running slow, people think that they need to free up some storage. That's not right. Remember that if computers are running slow, they don't have the available desktop space to spread out all the paperwork, post-it notes, and staplers and work comfortably. In other words, there isn't enough memory. There's no need to start deleting files from your hard drive or SSD. Just close some programs you're not using and things should speed up a little bit. Hopefully, if you ever see something like this ad, you at least now know what some of this all means and make smart purchasing decisions if you're in the market for something new. Remember the basics: memory, processor, and storage. Find a good balance based on what you're going to be doing with your new computer so that you're not buying too much.